All right, we're going to look at arc length with degrees. And we had already finished up arc length with radians. And if you remember arc length with radians, that was just simply S equals to R theta, where we had our radians and we had our radius, okay? We can use both. It doesn't really make a difference. And let's go ahead and check out number one, and we'll both use radians and radius for this, okay? So the arc length formula, if we have degrees, is simple. We just say, okay, well, I know that the arc length is going to be equal to the degrees over 360 times 2 pi r. And in this case, the degrees is 315. So I just simply write 315 over 360 times 2 times pi times the radius, which is 11. In other words, something simple is this is really just the fraction of the circle. Okay, so the fraction of the circle is 315 out of 360 degrees. Once we know that, it's as simple as just coming over and typing it into Desmos. So 315 divided by 360. And then we just type in 2 times pi times the radius of 11. And that gives us 60.47, or we could just simply write 60.5. So the arc length in this case is 60.5, and it is going to be in feet because we are talking about the circumference. Now, is there another way? Could we do this easily by converting it back to radians times radius? Well, absolutely. We can actually make a really good approximate version of this if we want to use S for arc length like we do with radians and radius. We just say, okay, the radius is simply 11 times radians. Well, what is 315 degrees divided by 57.3? And why is it 57.3? Well, because there's one radian is equal to 57 degrees. So we take 315, we divide it by 57.3, which is our approximate, which gives us 497 or 5.5 radians. So 5.5 radians. And what is 11 times 5.5? Well, we simply just say, well, 11 times 5.5. Notice that it gives us 60.5. So it gives us the exact same thing. It gives us 60.5. And now this is more approximate because we converted our degrees over to radians by using 57.3. But that's a very good way of doing it as well. There is arc length with degrees. We can convert it over to radians, or we can just go ahead and use the arc length formula, degrees over 360, or fraction of a circle times the circumference, 2 times pi. Hopefully that helps out.